Alright, so section 6.5, factoring binomials. How do we understand binomial? A polynomial with how many terms? How many terms? 2 terms, right? Yes. And other factoring techniques, okay? So we are going to learn 2 formulas today, okay? 2 types of the formula. The first type is called what? Factor a difference of squares, okay? What does difference of squares mean? It's a difference of what? Squares, okay? So how to factor a squared minus b squared, this type of the binomial, right? And then second objective is what? Factor a perfect square trinomial, okay? So what is a perfect square trinomial? Okay, so later you will know. We have this kind of form: a squared plus 1 minus 2 times ab plus b squared, okay? So why it is called a perfect square trinomial? Because eventually we can factor this trinomial into a perfect square, okay, as a square of something, okay? So we're going to learn formulas, these 2 types, okay? Now let's look at the first type, okay? First type of the formula. Recall from section 5.6 what happens when you multiply 2 binomials of the form a plus b times a minus b. See the example. When we multiply x plus 3 times x minus 3, what can we have? If we follow you, we will use formula. X plus 3 times x minus 3, can we follow you?
Yeah.
Yes, we can follow you, right? So let x times y, this x times by easy size give us x squared. This x times by negative 3x. 3 times x plus 3x. 3 times negative 3, negative 9. Can we simplify this further? Yes or no? Yes. Well, the negative 3x, we have positive 3x, right? So this x term cancel out, right? So eventually we get what? An x squared minus what? 9, right? Right, guys? Alright, now the thing is, okay, reversely, if I'm going to let you factor x squared minus 9, this is a binomial, right? With a difference of what? 2 squares. Why? Because 9 can be written by what? 3 squared, right? So, if we have a difference of the squares, how can we factor the difference of the square? How can we do that? Reversely, x squared minus 9 can be factored to be what? X plus 3 times by what? X minus 3, right? So can be factored to be x plus 3 times by what? X minus 3. Right, guys? So in general, what can we see? In general, if we have a difference of 2 squares, we can factor this binomial by what? X plus 3 times what? X minus 3. So this is a formula, okay? This is the formula. When we have, I don't want to write it like this, okay? A difference of squares, how can we factor it? Once we find a and b, we can factor this binomial by what? A plus b times by what? A minus b. Please cross out this given formula. It doesn't look, because we're factoring, we're not following, okay? So let's do a squared minus b squared can be factored to be a plus b times by a minus b. The thing is, we have to figure out what is a and what is a b in the binomial, right? And then a and b, they are what? Yeah, we have a squared and b squared as squares, okay? Alright guys, let's practice, okay? Let's look at question B. Let's factor x squared minus 49. Can we use a given formula? Is x squared a perfect square? Yes. Is 49 a square? Perfect square? Yes, it is what? 7 square. So what is a in this question? X. What is a b in the question? 7, right? So by using the formula of difference of 2 squares, how can we factor this binomial? What should we do? We should have a what? X plus 7 times by what? X minus 7. You guys, what's good? Okay, to factor binomial, we always have to check whether there is a greatest common factor or not, okay? If we do have the GCF, factor out the GCF at first. It is a general rule for all kind of the factoring question, okay? Now let's try question C, please. Factor 9 times x squared minus 25. Jose? 3x squared, right? Minus what? 5 squared. Oh yes, the difference of 2 squares. Okay, yeah, 2 squares. So what is A and B? A 3x, B is what? 5. So it can be factored to be what? 3x plus 5 times by what? Right? Alright, now let's try the question E. Negative x squared plus 100. How can we factor this binomial? Negative x squared plus 100 can be written by what?
Negative x squared.
Negative parentheses what? X squared minus what?
50. Wait, no. 10.
10 squared, right? Factor of the negative sign give us x squared. Factor negative sign, negative 1 give us a negative 100. Negative 100 can be written by what? 10 squared, right? Can we use formula to factor this? Negative x plus 10 times by x minus 10. Right? Now let's try question F. Factor 81x to the 4th power minus 1. Can we consider this is the difference of 2 squares?
Yes.
Yes. 81 times x to the 4th power can be written by what? 9 times x square. You agree with me? Because 9 square is 81, x square is x to the 4, right? And 1 can be written by what? 1 square, right? So we're able to factor, right? So let me use my red pen, okay? So what is A?
9x squared.
What is B?
1.
1, yes. So it can be factored to be 9x squared plus 1 times by 9x squared minus what? 1. Are we done for the question? Can we keep on factoring?
Yes.
9x squared can be factored to be what? 3x parentheses square, right? 1 can be written by 1 square. So we can keep on factoring this difference by 3x plus 1 times what? 3x minus 1. Yeah, so when we factor, we have to factor it completely, okay? Completely. Alright, so, question?
Okay, you just do 9x squared
Plus 1.
plus, but the minus under it in 1 parentheses and then times that by 2.
You want to factor this?
Yeah, so it's like, it's going to be the same thing, but just put 2 after the parentheses.
When we factor a binomial, it has to be a difference of 2 squares. Because, okay, I think I know your question, okay? A squared plus b squared, can we factor this by, what do you want to factor it? A plus b times by a plus b? Are they equals each other?
Yeah.
Yes? Okay, on the left it is a squared plus b squared. On the right it is what? We're going to follow, right? So a times a is what? A squared. A times b AB. B times A, AB. B plus B times B, B squared. So A plus B times A plus B equals what? A squared plus 2 times AB plus B squared. Then this equals A squared plus B squared. Ooh. Only when we have a difference of the squares, we can factor A to be what? A plus B times A minus B. But if we have a plus, we're not able to keep on factoring. Okay? So now let's look at this question I. Can we factor x squared plus 9?
No.
Ooh, x squared minus c squared. Are we able to keep on factoring this? No. This is called prime. Okay? If a polynomial is not able to factor, okay, to be factored, it's called a prime polynomial. Okay? Prime polynomial. Alright, so let's try some more questions. Okay, some more questions. Can you give it a try for h? X to the 4th power minus 4. Jose?
Yeah. I did 36x squared minus 49.
The x squared plus 2, right? Times by x squared minus what? 2.
Oh, I did the wrong one. Oops.
Which one did you do?
K.
You did a K? Okay, so h, see, Cameron, x squared minus 2 squared, right? So this is A, this is B, right? So A plus B times A minus B, right? Can we keep on factoring this? Is 2 on any square, any real number square? No, so we can stop it here, okay? Yeah, we can stop it here. So K, Jose just did this one. 72 times x squared minus 98 times y squared. How to factor this binomial?
So I did 36x squared.
36x squared? 72x squared minus 98 at y squared. How to factor this binomial? Is 72 a perfect square of a number? 72 is a square of a number? 98 is a square of a number? No. Any GCF, 72, 98, any greatest common factor? 72 has a common factor 2, right? 98 common factor 2. So GCF is what? 2, right? So let's factor out the 2 and see what we can get. So if 2 is out, what do we have inside of the parentheses? 2 times what equals 72x squared?
Just 36.
Yeah, 36x squared. What times 2 equals negative 98y squared?
49.
Yeah, negative 49y squared. And then 36x can be written by 6x squared, right? Minus 7y squared, right?
Yeah.
So what is A? 6x. What is a B? 7y, right? So 6 6x plus 7y times by 6x minus 7y. If there is a greatest common factor, always factor out the greatest common factor at the first. Always, okay? Alright, so this is this formula, okay? The difference of two squared formula, okay? We can factor like this, okay? Now let's looking at how to factor perfect square trinomial, okay? So remember in the previous section we did multiplying of two binomial with the form a plus b times a plus b. Okay, so how can we follow this? What should we get? X plus 3 times x plus 3. What do we have? What will we have? We have x times x equals what?
X squared.
X squared. X times 3 plus 3x. 3 times x, 3x. 3 times 3 is what? 9. So eventually we're going to have what? An x squared plus what? 6 times x plus 9. You guys feel good? Now I'm going to ask you, factor x squared plus 6x plus 9, this trinomial. Are we able to factor this trinomial? We did have a factor trinomial in the previous sections, okay? So by what? Grouping, right? Also by value. Remember we learned that, okay? Now guys, let's see. Because it told us x plus 3 times x plus 3 equals x squared plus 6x plus 9. So reversely, x squared plus 6x plus 9 can be factored to be what? X plus 3 times by x plus 3. You guys see that? Okay, now the thing is, for what kind of trinomial we can get this conclusion? If in this trinomial we have two terms, they are perfect squares. X squared is a perfect square, right? And 9 it is a what? 3 square, right? It is a 3. It's also a perfect square. And then the middle term is what? Twice of x times by what? 3. Is 6x equals 2 times x times 3? Yes or no?
Yes.
Yes. Then we say, oh, x squared, 3 squared. Oh, let's factor it to be what? X plus 3 times by x plus 3. So in general, everybody, okay, I'm going to write the first formula, okay? How to factor a perfect square trinomial? If we have a squared plus 2 times a times b plus b squared, okay? Then, see, along the 3 terms, 2 terms are perfect squares. The middle term is twice of a times b. Then we can factor it by what? A plus b times by what? A plus b. Okay? So now I'm going to let you guys practice, okay? Practice. So let's factor x squared plus 12x plus 36. See whether we are able to use this formula or not. X squared plus 12x plus 36. Among the 3 terms, do you have 2 perfect square terms? What are the 2 terms? X squared. And 36 is what? 6 squared, right? And then is a middle term equals 2 times x times 6. Well, 2 times x times 6 equals 12x, yes or no? Yes. So what are the a and b in the question? A is x, b is 6. So we can factor this trinomial to be a plus b times a plus b. Okay. Yeah. Depends on the middle term is a positive sign. We have a plus b times a plus b. Okay. Well, the other formula is telling us if we have a squared minus 2 times a times b plus b squared, see, among the 3 terms, 2 terms are squares, perfect squares. The middle term is also 2 times a times b, however, it's negative. Then it can be factored to be what? A minus b times by what? A minus B. Okay? Let's try question E together. 49x squared minus 42xy plus 9y squared. Factor this trinomial. Is 49x squared a perfect square? 49x squared can be written by something square?
Yes.
Yes, by what? 7x squared. Ooh, good. How about 9y squared? 3y squared, right? So, the middle term equals twice of 7x times by what? 3y. 2 times 7x times 3y, is it equals 42xy? Let's see. 2 times 7 times 3, is it equals 42? 2 times 7, 14. 14 times 3 equals 42?
Yes.
And then times xy, right? However, here it is negative. So, what are the A and B's? A is 7x, B is what? 3y, okay? So it can be factored by what? 7x minus 3y times by 7x minus 3y. Depends on the middle term's sign. If this is negative, we factor to be A minus B times by A minus B. Alright, I'm going to let you try the H and I. I'll give you a couple minutes to try the H and I. If there is greatest common factor, fact out this greatest common factor out. Okay, factor that out first. Think about 75, 90, 27. Any greatest common factor? Don't just stare at it. Factor, right? Remember factor? How do you find the greatest common factor for 75, 90, and 27? What do we do? Remember? We factor, right? Factor 75 to be what? 325 and 5 and 5, right? So 355. How about 90? So there's no 2, right, in this factor, so we don't want to start from 2, we start from 3. So 90 can be factored to be 3 times by what?
30.
30. And 3 times by what? 10. And then by 2 and 5, right? And 27, 3 and 9, 3 and 3, right? So any common factor can you tell?
3.
3. How about 5? No. Right? So the 5 has to show up for all of the, numbers factors. So no 5. How about another 3? No. See, this 3 shows up here for 2, but not for 3. So what is a GCF this time? 3, just 3, okay? So GCF is 3. So let's factor out those 3. And then I'm going to ask you, what do you have here inside of the parentheses? Inside the parentheses, Cameron?
I put 25x squared.
Okay.
I put positive 30x
plus 9, yes, good. And then are we able to factor this trinomial? 25x squared can be written by what? 5x squared, right? 9 can be written by what? 3 squared. The middle term, 2 times 5x times 3. Is it equals 30x? 2 times 5x, this is times, okay? Times.
Yeah.
10 times 3 is 30x, right? And then it's a plus. So what will be the A and B in the question? A is 5x, B is 3, right? So let's factor it to be what? 5x plus 3 times by 5x plus 3, because the middle term is a positive sign, so we plus. Right? Can you try I? Number I. If there's GCF, fact out the GCF. What is GCF? 5, yeah, okay. So GCF is 5, so factor that out. So what do you have inside the parentheses? You have a 25x squared minus what? 30x plus 9, did you? It seems very similar to the previous question, right? The only difference is the middle term is negative 30x, right? So what do you have eventually? 5 times by what? 5x minus 3 times by 5x minus what? 3. Do you get the same answer? You do? Okay.